So we've covered how to use the Polar's read CSV function before, but that was recorded prior to the 1.0 release. There have been several changes made to the function since that time, so we're going to redo this video with some of the more significant updates. The read CSV function has many parameters that you can use to work with any CSV file that you have. What I'd like to do here is take a comprehensive look at some of the more relevant parameters. For starters, we're going to keep it very simple and use only the default arguments. So let's go ahead and expand this here. And you can see I've already got it pre-filled in. I'm just going to explain what's going on. I'm not going to be typing. I think that wastes too much time. And I certainly don't want you to have to wait while I type everything out. So everything's going to be on display here. Our first step here is to import polars as PL. Next, we'll define a variable called data and set it equal to pl.readCSV. And within the function, we'll type the path to our CSV file. And the CSV that we're utilizing in this demonstration is an employee's CSV file. Now that we've defined our new variable, we want to display our data frame. And in Jupyter Notebooks, you can do that by simply typing the variable name, which we've done right here. And to display just a few rows, we're going to use the head function on the data frame. That's going to give us the first 5 rows of data. So let's go ahead and run this. Let me try that one more time. There we go. For some reason, it didn't display the data frame. Okay, so as you can see, we now get a data frame in a nice tabular format. We also get the shape of our data frame in a tuple format. You can see that here. And just a note here, it is counting the rows and the columns. In our case, we only pulled 5 rows. There are more than that in the CSV file. But when you use the head function, that gets displayed as the number of rows that you have. Okay, so pretty simple, right? And the read CSV function makes it easy for us to read in our data. That said, we've only really scratched the surface on this function's capabilities, and there's definitely a lot of different circumstances and scenarios where you might need to tweak some of the parameters, not simply just go with the defaults that have been set up, and we're going to kind of walk through some of those now. Let's start by reviewing the schema overrides parameter. By default, polars will try to pick the best data type for any given column. This parameter is called infer schema. While it does a pretty good job at interpreting the data, it doesn't always hit the mark, and sometimes we don't get the data type that we want to work with. When we use schema overrides, we tell polars specific columns we want to explicitly declare data types for. For example, our salary column was read in as an integer 64, and our date columns were brought in as a string. We want to fix that by using the schema overrides parameter. So let's go ahead and scroll down just a little bit. I'll expand this. Let me explain what's going on here. So we're once again calling the read CSV function, and we're passing our file path. And now we're adding on the schema overrides parameter. In there, we're passing a dictionary with the columns that we want to change and the data types that we want to change them to. Now, if you're not sure what data types Polars has to offer, you can look at the documentation. You do call them by typing this pl dot, and then you can call any of the data types that are listed in the library. In our case, we want to change this one to a float 64, and then we want to change our date columns to a date data type. Okay, let's go ahead and run this cell. And when we display the data frame, our salary column no longer has an integer 64 data type. Instead, we now have it displayed as a float with decimals. And our date columns are not showing as strings, but are now actually date data types. Now, schema overrides are helpful for when you're initially opening CSV files, but you may want to use a more long-term solution when working with data pipelines. Read CSV has another option called schema. With this argument, you can actually pass a schema object that maps the data types you want. If you're interested in learning more about this functionality, I do have another video for that goes into greater depth on the topic. You can check that out in the video description. Okay, we're going to move on here to try parse dates. And with schema overrides, we were able to explicitly declare that we wanted our date columns opened with a date data type. But you might have noticed, if we scroll back up here just a little bit, that the default for dates would be a string, right? So that's kind of the default behavior for polars. There is an argument that we can pass if we don't want to explicitly declare like we did here. We can use the try parse dates parameter. Now let's go ahead and expand this so you can see what it looks like. Now in this case, we're going to once again use the read CSV function. The only difference in this one is we're now using just the try_parseDates parameter, and we're setting it equal to true. So what this is essentially going to do is it's going to try to look for common date patterns within the CSV file, and if it detects ones that it recognizes, it will successfully read it in. So I will make a disclaimer here. It doesn't 100% work with every single date type that's out there, but it works pretty good for pretty standard dates, which is kind of what we have already right here. So let's go ahead and run this. And you can see, once again, we didn't explicitly declare that we wanted these changed. You can see that the salary column is back to that integer value. But since using the try_parseDates argument, it did successfully find a pattern within our date columns that allowed it to be read in as a date data type. Okay, next up, let's discuss the hasHeaders argument. As a data professional, you are bound to work with CSV files that do and don't have column headers in the first row. By default, Polars assumes that headers exist. However, you can tell Polars that the first row of data does not contain column headers using the hasHeaders argument. So let's go ahead and scroll down a little bit more again, expand this. So in this case, once again, the hasHeaders parameter is usually set to true by default. But if you have a file that doesn't have those headers, you can actually come in here and you just pass the hasHeaders. Excuse me, I've been saying hasHeaders. It's just hasHeader, no S on the end of that. So just a quick correction there. But you basically just need to set that to false, and then it will read it in as if it doesn't have headers. So let's go ahead and run this. And when we run the code, we can see that something is wrong. Obviously, this file does have column headers. So again, for our purposes, we don't have a file that we're needing to read in right now that doesn't have those headers, but this is an option for you if you needed to ever use it. A somewhat related parameter is called new columns. Now, this allows us to overwrite the column headers by passing a list of column names. And if you're working with files without column headers, this is actually a perfect way for you to get greater clarity. You can see right here that we have column 1, column 2, column 3. That's not super helpful. Generally, when you're working with data, you should have those column headers. So we're actually going to kind of walk through, if you have those files without headers and you know what that column headers should be, we're going to talk about how the new columns parameter can do that. So let's go ahead and expand this. Now you can see that we've declared a new variable here, and it's just a list of the column names. And what we're going to do on this first example is keep the hasHeaders argument as false, just so you can see how that works. And then what we need to do is use the new columns parameter, and in here we just pass our list of column names. So this will all run together. We haven't read in or created this new variable yet, but we will as we're running this code. So let's go ahead and run this and see what we get back. Okay, so now instead of having column 1, column 2, and so on, we have our new column names. Okay, so it has that capability to overwrite the headers that maybe don't exist, but it also can overwrite headers even if they do exist. So we're actually going to, on this second line right here, we're going to use the same variable that we used before, got our list of column names, and this time we're going to remove that hasHeaders. I keep saying hasHeaders. It's hasHeader. We're going to remove that argument from this function right here, and then we'll see that it should have everything looking correctly here. So let's go ahead and run that. Okay, so we've just got our first row of data starting right here, which is great, and we've effectively renamed our column headers. Now, if you're interested in learning more about column headers and how to manipulate them in Polars, I highly recommend you check out another video I put out recently on case conventions. I'll include a link to that in the description below. Okay, the final one we're going to look at here is the separator. And believe it or not all CSV files are comma separated. And that might come as a shock considering CSV means comma separated values. But there are different delimiters that you can use, and you can be pretty free about how you use them within certain limits. Some of the most popular separators include semicolons, tabs, and pipes. So in addition to the commas, there's semicolons, tabs, and pipes that you can also use as CSV files. And the read CSV function can open those files. Now we're going to get some practice with this by opening a tab-separated file. If you have downloaded the entire Polars Code Academy repo, you should have access to the employees TSV file that we'll be using. Let's go ahead and expand this. And you can see that our data set is different here. It's not going to be the exact same because it's a TSV file. It's going to be tab separated. And I think even the data is a little bit different. So don't let that throw you. It's just a different employees data set. Anyway, let's go ahead and try to read this in just with the default arguments just to see what happens. And as you can see, we have all of our data in one column. You can see kind of the tabs here, and it's just not correctly parsing that data. Now, in order to fix this, we can call the separator argument, which is what we're doing here, and we're passing a \t. And once we've declared that, we should be able to successfully parse this data. And so let's go ahead and run this. And now when we run the code, we get the data frame that we'd expect. Okay, that's all we have for this video. Once again, I'll invite you to check out the other 2 videos I recommended earlier. If there are any other topics you'd like to see covered on our channel, please comment below. Thank you for watching, and we'll catch up with you soon.